47 million years before the first dinosaurs, Earth belonged to another dynasty. This is the Permian Period, spanning 299 to 252 million years ago. The continents had fused into a single superland called Pangaea, its interior baked beneath dry skies, while violent seasonal monsoons drenched the coasts. Here, life adapted and then flourished. Flip, our time-traveling companion, has arrived in this alien world. But no cats roam here. She must watch from the shadows, for today's rulers are unlike anything she has ever seen. The Permian was a land of extremes. Early in the period, ice sheets still clung to the far south. But as Pangaea formed, its interior lay far from the sea. The result? Scorching summers, freezing winters, and long droughts broken by brief, violent rains. Rivers carved red sediments across the floodplains, laying down the layers we now call the red beds. Here in what is now Texas and Oklahoma, a floodplain community thrived. In shallow pools, broad-headed amphibians lurked, reptiles darted between shrubs, and from these lands emerged one of the most iconic creatures of prehistory, Dimetrodon, a predator often mistaken for a dinosaur, but in truth a distant relative of mammals. Dimetrodon was no dinosaur. It belonged to the synapsids, the lineage that would one day lead to mammals. Its towering sail rose from elongated vertebrae, while its jaws bristled with serrated teeth of different sizes. This feature, known as heterodonty, made it a precise and deadly hunter. Most fossils are found here in the early Permian red beds, dated to nearly 295 million years ago. But what purpose did the sail serve? Some paleontologists argue it regulated body temperature, absorbing warmth in the morning, radiating heat at midday. Others suggest it was a display structure, perhaps to intimidate rivals or attract mates. Evidence hints at both. Whatever its function, the sail made Dimetrodon one of the most distinctive predators in Earth's history. Sharing the same floodplains was Edaphosaurus, one of the earliest large plant-eating vertebrates. Like Dimetrodon, it bore a sail. But its neural spines carried curious crossbars, unlike anything seen in predators. Its jaws housed tooth plates, perfect for grinding tough vegetation. Two unrelated lineages, two very different sails. When seasonal rains returned, the waterways filled with life. Ariops, a giant temnosponal amphibian, lurked like a crocodile. Smaller creatures such as Diplocalus, with its boomerang-shaped skull, glided through the shallows. Even Flip must tread carefully here. Amphibians in the Permian grew far larger than anything she knows. Vegetation shaped the landscape. In the southern continent of Gondwana, vast swamp forests were dominated by the seed fern Glossopteris. Elsewhere, early conifers spread across drier uplands. Ginkgophytes appeared, their fan-shaped leaves familiar to us even today. By the late Permian, even the first true cycads had arrived. These forests laid the foundation for complex ecosystems. As climates grew harsher, life shifted. Huge, lumbering caseids, like Cotylorhynchus, grazed on tough plants. Powerful Dinocephalians rose, then disappeared. The synapsids continued to diversify, giving rise to a more advanced lineage, Therapsids, creatures with skulls and jaws closer to mammals. By the late Permian, life's strongholds had shifted. On the Russian plains and in South Africa's Karoo Basin, new forms emerged. Here, the Therapsids reigned, animals that looked far more mammal-like than their early Permian ancestors. Foremost among predators were the Gorgonopsians, sleek, long-limbed hunters with massive saber-like teeth. Enos transavia, the largest known, dominated the late Permian of Russia. With jaws that opened wide and canine teeth that cut deep, they stood as apex predators of their age. Facing them were powerful plant eaters. The armor-plated Scutosaurus, a pariasaur, browsed low vegetation. Herds of Dicenodonts, beaked Therapsids with tusks, moved between scarce waterholes. Among them was Lystrosaurus, stocky and resilient. Though modest in size, it would one day outlive nearly all its neighbors. In the oceans, life still thrived. Reef systems built not by corals but by sponges and algae supported a variety of creatures. Brachiopods anchored to the seafloor, while coiled ammonoids swam above. Trilobites, ancient survivors from the Cambrian, dwindled, on the brink of extinction. Then disaster struck. About 252 million years ago, in what is now Siberia, colossal volcanic eruptions, the Siberian traps, blanketed Earth with lava. These eruptions pumped vast amounts of carbon dioxide into the atmosphere. Oceans warmed, oxygen levels fell, and acidic waters corroded life. Toxic chemistry spread across land and sea. It was the greatest extinction in Earth's history. More than 90% of marine species and around 70% of land species vanished. Whole ecosystems collapsed. The mighty Gorgonopsians disappeared forever. Trilobites, the icons of Paleozoic seas, were gone. The age of synapsids had ended in devastation. Yet from destruction came survival. Lystrosaurus, small and stubborn, endured. It would dominate the Triassic, paving the way for new lineages. Dinosaurs, crocodile-line archosaurs, and eventually mammals. Out of catastrophe, the seeds of future worlds were sown. Flip's journey through the Permian is complete. Ahead lies the Triassic, the dawn of new rulers, and the first rebuilding of life after the Great Dying. If you enjoyed this journey into deep time, join Flip for the next adventure. Like, subscribe, and share, and together we'll continue exploring the story of life on Earth.